Which one's the fast car? Which one's the slow car? And how do you? And then the next question is, how do you know? So tell me, which one's the fast car? Which one's the slow? But what is it about both those plots to tell you that one of the plots is definitely the slow car, but based on what? Slope, right? Yeah. Slope is what? Say it. Well, flatter, right? Yeah, it's flatter. And tell me about the fast car. Describe its slope. Exactly. Okay. Label those. Given those plot shapes of the fast car and the slow car, first of all, how do you know which one's the slow car? Which one would you label slow car?
Because I did circles around the fast car and triangles.
You got a key over there somewhere? Good, there's a key. But how do you know well, the next question is, how would you describe the velocity of each car? Would you say that it's increasing, decreasing, or constant?
Of the fast car, it's constant
Right.
and it's positive
Good.
increasing.
Well,
It's not increasing, but it's positive.
that's right, it's
yeah.
positive. Yeah, what about the slow car?
And then this one's constant negative.
So the slow car, you can see it starts at 250, and the fast car, well, it starts at 0. If I pointed the slow car towards the fast car, when and where would they hit? When would the fast car hit the slow car, based on your plot? And where would they be, and what time would it be? How would you find that out, given that plot? What do you think? Yeah. So why don't you draw a dotted line down, a dotted line over? Isn't that the collision point where they both share the same right time? And yeah. So do that. Okay. Again, draw a dotted line down from when it will hit, and a dotted line to the left to where it would hit. And that we now can predict where the slow car would hit the fast car if they were headed towards each other 250 meters apart. Actually, not 250 meters apart, 250 centimeters apart would be where they would collide.